Hi everyone and welcome to the new video. In the previous part I explained how to use Raspberry Pi outputs and we were able to blink the LED. In this part I will show the opposite thing and we will see how to use the inputs. For example, if you want to connect a button to the Raspberry Pi and you can assign some action to it. As a bonus I will show how to connect the motion sensor so we can do some fun stuff. Let's get started. As a reminder, our first goal is to connect the button to the Raspberry Pi. And here we have two options, a so-called pull-up and pull-down resistors. Let's figure out how it works. Let's say we have a Raspberry Pi and it has a power line, it has a ground line and it has a pin. The pin by default is connected to a power with a so-called pull-up resistor. And the button is connected to the ground, but by default, as we see, it's not pressed. In this mode, by default, our signal will be 3.3 volts, and only when we press the button, it will go to 0. And when we release the button, it will go back. So, interestingly, as we can see, our signal is reversed. So, when we press the button, as we can see, the signal goes from 1 to 0. This mode is called pull-up, and we can see why, because this signal by default is connected to the logical 1, so this resistor is pulling this up. The second mode is opposite. Let's say our input is always connected to the ground, and as we can guess, its signal is 0, and the button is connecting to the power line. The same idea, when the button is not pressed, the signal level is 0, and when we press the button it will go to 3.3 volts, and when we release the button it will go back to 0. So we have a reversed signal 0, 1, 0. This configuration called pull down. The third mode is when there is no resistor at all. Usually it works when we have another hardware that has their own logic and we just connect it as a black box and we just read the pin as is, and this device produces, usually this is an output and this is input. There is an important note: in the third mode, when the no resistor is connected, the pin is in the so-called floating mode. So especially if we have a long wire, it can get some electromagnetic noise, and as we can guess, this signal can be read by Raspberry Pi or like 0 or like 1. If nothing is connected, it's usually not a problem, but if, for example, if we log pin state, then it can be a problem for us because we will just log a lot of noise. In this case, we just need to be aware of that. Okay, it's time to write some code. First, as usual, I need to import the required libraries, and I also need to specify our pin. As a reminder, this is a pin out of the Raspberry Pi, so as we can see, I am using pin 12. As a next important step, I want to introduce the logging library. It's a very convenient thing in Python. Earlier I used printing like print something. It works, but logging is much more powerful. For example, as here specify the time and the message. As we can see, when I run the code, it will automatically add the timestamp to our message, which is much more convenient. Then, as discussed before, we need to specify our input, and here I use the put down mode. So we will have a pull down resistor. There is an important note I forgot to mention. I showed pull up and pull down the resistor on the connection diagram, but practically it's already included in the Raspberry Pi, so technically we don't need an extra resistor for that. We only need to enable it in the code. The connection diagram will look like this. The easiest way to read the pin is just to use GPIO input like this, and I will also print this. To be honest, this method is a bit stupid. I will show later how to do it better, because technically our program is doing nothing and only reading the pin in the infinite loop, but for testing it's good enough. So now I can run the program, and we can see, because we are using pull down mode, our outputs are 0. And as we can see, when I connect pin to the power, it's changed to 1. As I mentioned before, this is not an effective way to read the pin. In this video I will show later how to do it better, so stay tuned. The second mode is pull-up resistor. All we need to change is this constant. And technically our code will work as before, but of course we need to change the wiring. I need to connect my button to the ground because the pin is connected to up to the 3.3 volts, and while connecting to the ground we will switch it to 0. Let's see how it works. As we can see, our values are 1 by default, and only when we connect pin to the ground they are changing to 0, so it works. As a bonus, I will show what happens if we don't specify any resistor. By the way, there is a convenient way in Visual Studio Code. If you click Go to Definition, you can see the source code, and you immediately know which constants you can use. For example, I can copy resistor off and I can paste it in my code. And now our pin is in floating mode, and if I run it again, we will see what happens. So our pin is 0, but when I touch the pin, it's going to 1, and it stays 1, and then it randomly goes to 0, and it randomly goes to 1, and they say I'm not touching it now. For example, if your application is designed to do something when the pin is changed, it's not convenient. As a second fun approach, let's turn the LEDs when the pin is on. We can copy the code from our previous lesson. Only I need to do is initialize the pins. Let's do it. Here I set the resistors to pull down, so let's see how it works. As we can see, all our 3 LEDs are blinking when we press the button. We can see more fun stuff. For example, I can set a logical inverse to this pin. Now I can run application again, and we can see that pins are blinking in the opposite order. As I promised at the beginning of the video, I will show a more effective way to read pins. As a reminder, we used a while true loop where we read all the pins. Instead, we can use a callback function that will be called automatically. I will need to change my code a bit. First, I am adding the callback function. I will change the LEDs when the pin is changing. So as we can see, I added a method, and in this method I read the pin. I print the same value, and just for fun I am setting 2 LEDs as an output, so we will see that it works. As a second step, I need to add the callback, so our function will be triggered. As we can see, there is an event detect method, and here I specified the pin number. Here I specified that I want to subscribe to both changes, and this is my callback that will be used. And now I can clean the event loop, and it will practically do nothing. It will just prevent application from closing. So the all logic is removed here and here. We subscribe to a pin change, we get this pin change, and here we have all our logic. As we can see here, I set this pin to the same value, and this pin will have the inverted value. Let's see how it works. Now, as we can see, our output is empty because we don't have this infinite loop with print. When I press the button, we can see the events, and also we can see that our LEDs are blinking as we expected. So it works. As the last part of the video, I will show how to connect the motion sensor. Infrared motion sensor is a simple, inexpensive device. It costs about $10 US, and it needs only 3 wires to connect: power, ground, and input. Let's see how it works. Code changes are minimal. Here I specified all 3 LEDs to be on when the motion is detected. I set pull-up resistor to off because this device has their own resistors. All other parts are the same, so let's see how it works. I run the code, now no motion detected, and then when I move the hand before the device, we can see that the status is changing. And as expected, LEDs are also blinking. The sensitivity and time delay can be adjusted. There are 2 potentiometers at the side, so viewers who wish can do it on their own. As we can see, it works. In this video, I explained how to use inputs on the Raspberry Pi. If you missed the previous video, you should also watch how to use outputs. Now we can use both inputs and outputs, and we can use real IoT. In the next video, I will show how to connect this board to the Home Assistant so we can integrate it to our smart home. The full source code for this lesson is available on my Patreon page. Feel free to visit it. Thanks for watching, and see you next time.